So we're in section 4.4 CPCTC. So for a recap, for polygons, that's where we started at the beginning of chapter 4. To show that polygons are congruent, we need to match corresponding parts. So we need pairs of angles. We need those to be congruent, and we need pairs of sides congruent. So for polygons, we have to match up all the sides, all the pairs of sides, and all the pairs of angles. And then for triangles, we came up with a bunch of shortcuts. And all of our shortcuts just made it so that we just needed to match 3 pairs of parts. And those 3 pairs came from, we talked about side, angle, side, 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 angle, side, angle, and angle, angle, side. So those are the 4 ways that we can match up 3 pairs of parts on triangles to show that they're congruent. We said that angle, angle, angle does not work. So that's a way we can match up 3 pairs of parts, but it doesn't work. We can't show triangles are congruent with angle, angle, angle. We also, and I'm going to say today, that the other way that we can match up 3 pairs of parts, SSA does not work. We'll go into a little more detail about SSA when we talk about right triangles. But for now, one way to remember that SSA doesn't work is if you turn it around and write it the other way, you get something that shouldn't say in math class. So SSA does not work. So these are two ways that we can match up 3 pairs of parts. That doesn't work to show that the triangles are congruent. As much as we'd like them to, they don't work. So that's what we've done so far in the chapter. What we want to talk about today is what we do after we show that triangles are congruent. We can say that all the matching parts are congruent. So we use 3 pairs of matching parts to show that they're congruent. Well, once we know that, then we know all the rest of them are congruent also. And the way that we say that is that corresponding parts of congruent triangles are congruent. Or we're just going to take this and turn it into an acronym. CPCTC. CPCTC is short for corresponding parts of congruent triangles are congruent. It avoids us having to say that over and over when we want to use that idea. So what we do, big picture, when we want to show that some parts of triangles are congruent, we show that the triangles themselves are congruent using ASA, SAS, all of these, any one of those things, and then we use CPCTC to say that the parts of the triangles are congruent. So that's, in general, in this section, that's our plan. show that the triangles are congruent, and then use CPCTC. So all I want to do now is go through a couple of examples of applying this idea. So CPCTC we always use after we show that triangles are congruent. We never use CPCTC as a reason to say that triangles are congruent. We use it after we show that triangles are congruent. So let's go through a couple of examples. So here's our setup. We have this kind of hourglass shape. And we'll label this M, Q, P, O, and N. And we're going to be given that segment MP and segment NQ bisect each other at point O. We want to prove that segment MN is congruent to segment PQ. So our plan is we want to show that these triangles are congruent. And then we can use CPCTC. So we want to prove that the triangles are congruent. If the triangles are congruent, then all the matching parts have to be congruent. And then we can say that those two segments are congruent. So let's write our proof statement and our reason. And I'm not going to rewrite the given stuff. So I'm just going to draw a little arrow here. All that stuff is given. All right, so let's look at that given information. It says segment MP and segment NQ bisect each other at point O. What does bisect mean? Cut in half. They cut each other in half. So right there at point O, each of those segments is cut in half. Well, what does that tell us about segment MO and segment OP? They have to be the same. They have to be congruent. So I can mark those congruent. And segment segment NQ is bisected at point O. So we can mark segment NO and segment OQ congruent. So I'm going to say segment MO is congruent to segment OP, and segment NO is congruent to segment OQ. And my reason for that would be the definition of bisect. That's what bisect means, is that it's been cut into two equal pieces. All right, so we know we need 3 pieces of information to show that our triangles are congruent. What's our third piece of information that we can figure out there, based on the drawing that we have? Yeah?
Angles MON and QON are congruent.
QOP. Yeah. These are congruent because they are what kind of angles? Vertical. So we would say angle MON is congruent to angle, and I'm going to write it the other way, POQ. And that is vertical. Vertical angles. Well, now we have side, angle, side, and side, angle, side. So I can say that the triangles are congruent. So I'd say triangle MON is congruent to triangle. And we need segment MO to be congruent to segment PO. So I'm going to say POQ. And that reason would be side, angle, side. Well, now we have the triangles congruent, so all the matching parts have to be congruent. And segment MN matches with segment PQ. So I can say MN is congruent to PQ, and that reason would be CPCTC. Corresponding parts of congruent triangles are congruent. So when we use CPCTC, show the triangles are congruent, and then use CPCTC to match up the parts that we're interested in. All right, questions there? All right, let's look at one more. So this setup is similar to our opener. We'll have a little bit different set of information. R, S, U, T. And I'm going to mark these and this. We're going to be given just what we've marked here. The segment RS is congruent to segment TU, and segment RT is congruent to segment SU. And we want to prove that angle T is congruent to angle S. So we want to prove that this angle is congruent to this angle. All right, our plan again. Show the triangles are congruent. Use CPCTC. So let's write our proof. Our statements and our reasons. Hopefully, we can see the start of this one, and really the whole thing once we get one piece. This one's not too bad. So that's our given information. Don't need to rewrite that. All right, so what can we figure out right away? Yep. RU is congruent to itself. Very nice. And the reason for that? Reflexive. Well, do we have three pieces of information to show that the triangles are congruent now? Yep. So I'm going to say triangle RUS is congruent to triangle, so RUS. I need RU to match up with RU, so it has to be RUT. That, the reason for that, what's our reason? Side, side, side. And then we can say, from our congruence statement here, S and T match up. So we can say angle T is congruent to angle S by CPCTC. Corresponding parts of congruent triangles are congruent. All right, questions? Okay.